Hey boys and girls, it's Mr. Rocker here, and I have a very cool video on ionic nomenclature. I want to quickly just review some things and give you the opportunity to go back and review what we've already covered. So first off, we need to know that ionic compounds are formed when a metal transfers electrons to a nonmetal. You have to be careful because there is one positive polyatomic ion. Remember that ammonium, while ammonium is not a metal, it does act sort of like a metal in ionic compounds. So metals and ammonium transfer electrons to nonmetals or negative polyatomic ions. And so remember, that's how you recognize ionic compounds. They begin with a metal. And that's important because you'll have all of them mixed together, all different types of compounds, and you have to identify what kind of compound it is and then properly solve it. Okay, remember that when we transfer electrons, we make ions. That's the key here. And that when we write a formula, we are balancing charge. We're balancing the positive and the negative charge in the compound because electrons lost equal electrons gained. Cool, huh? Cool. All right, so when we're writing formulas, we just first need to write the name of each ion, the formula for each ion. Sodium is Na plus 1, is plus 1 because it's in group 1. Oxide is oxygen, which has a negative 2 charge. Remember, ide generally indicates that it's going to be monatomic. There are only two polyatomics that end in IDE. That's hydroxide and cyanide. And then we say to ourselves, how many sodiums balance how many oxygens? Well, you should easily see that it takes 2 sodiums to balance that. So that formula is Na2O. So on the next one, calcium is plus 2, oxygen is negative 2. What do you notice about that one? Oh, yeah, they're already balanced. CaO. That's very nice. Very, very nice. Now, we're going to move on to lithium chloride. Ooh, lithium chloride. Well, lithium is just Li. It's in group 1, so it's plus 1. Chlorite. If it ends in ITE or ATE, that is a polyatomic. So I'm going to go to my polyatomic list. I'm going to look up ClO2 minus 1 is the formula for chlorite. Be careful there because there's a chlorate, there's a perchlorate, and there's a hypochlorite. They all have different number of oxygens. But they all have the same charge. That's convenient. That's very nice. All right. What does plus 1 and minus 1 do to each other? They cancel out. That's correct. I hope you said that out loud to your computer. If you did not speak to your computer, speak to it. It's your friend. It helps you. It takes care of you. Okay. Oh, why didn't I do this? Why don't I need those parentheses? Well, see, here, if we're not adding a number out here next to that polyatomic ion, we don't need parentheses on that one. But I bet we need parentheses on the next one. Calcium has a plus 2 charge. Nitrate, that is an ATE, so that's a polyatomic. NO3 minus 1. So how many minus 1s balance a plus 2? Did you say 2 minus 1s? If you did, you are correct. So we say CaNO3 2. Now we need a parentheses. We need a parentheses because we have multiple, that means more than one, polyatomic ions present. Multiple polyatomic ions present. Multiple polyatomic ions. So do we want to say 2 of oxygens or 2 of everything? We want to say 2 of everything. We have to be careful there because sometimes polyatomics don't have a subscript at the end to help us remember to put our parentheses. That's one of the very, very common mistakes. Let's go next to calcium phosphate. Calcium phosphate. Remember, you can pause this video anytime you like. Calcium is in group 2, so it's plus 2. And phosphate, 8 means it's a polyatomic ion. Looked on my list. It's PO4 minus 3. Oh, this is very interesting. What do I do with a 2 and a 3? This is a least common multiple kind of deal where you need to add up all your charges, but I'll show you a shortcut. A shortcut for 2 and 3 that save you some time is just take the 3 and put it down here. Take the 2 and put it down there. Not the charges, not the charges. Why don't we write charges? Did you say we don't write charges because they cancel out? If you said that, you're correct. Ca3, PO4, 2 is the answer. So what does that really mean? Let's review. Ca, Ca, Ca. There's 3 Cas, and each one has a +2 charge. That gives us a total +6. And we've got 2 phosphates, so PO4, PO4. And that has a -3 charge, and that gives us a -6. And that's the whole point of messing with the charges, is to make sure that they end up totally balanced. They have to cancel each other out. All ionic compounds are neutral. The ionic compound is neutral because the positive and the negative cancel out. Das very nice. Let's go on to the next one. Oh, what does this mean? There's a Roman numeral 3 in the middle of this one. I haven't seen that before. It's very confusing. What does it mean? It means that iron has a +3 charge. Iron is one of the elements. We wrote them on our table. Iron is one of the elements that has more than one possible charge. It can be +2 or +3. So in a name, only in the name, you have to designate what charge it has. So we put a +3. Hydroxide is one of our few polyatomics that does not end in ATE or ITE. You should get used to that one. It has a -1. Now, how many -1s balance a +3? Did you say 3? If you said 3, you are correct. So we say FeOH3, right? No, shout wrong. That's not right. What do we have to add to that to make it correct? Do I want to have 3 H's and 1 O, or do I want 3 of everything? I want 3 of everything. This is one of the ones that students miss the parentheses on a lot because hydroxide doesn't have a subscript down here to remind you that you need that parentheses. So remember that. And last, we have lead 4 cyanide. So that means Pb +4, Cn -1. How many -1s balance the +4? Did you say 4 of them? PbCN4. Very cool. Very, very, very cool. All right, so that ends writing formulas for ionic compounds. Let's move on now to writing names for ionic compounds. Oh, I don't have any examples pre-installed, but that's not a problem. Writing names for ionic compounds is quite simple. You just look at the formula. Let's say, for example, it's Na2O. When you write the name of the positive ion here is sodium. And then you write the negative ion, but remember that monatomic ions, this is a mouthful, monatomic anions, we change the ending to IDE. So we don't say sodium oxygen, we say sodium oxide. What do I need to do with that 2? Nothing. I don't need to do anything with the 2. Because, see, we already know, that the 2 is going to be there because we know the charges for sodium and oxygen. So we don't really need that. What about this one? Ooh, this one's going to be fun. NH4, 3PO4. Whoa. Wah. Wah. What is NH4? NH4 is not nitrogen tetrahydride. It is ammonium. It's a polyatomic ion. NH4 is the only positively charged polyatomic ion that we will work with. There are a few others, but they're not very common. And PO4 is phosphate. Now, phosphate, I don't need to change anything. See, we change monatomic. We don't change polyatomics. In fact, this is a very important thing you remember. Never, ever, ever, ever change a polyatomic ion in any way. Even up top, even up here. Don't worry, he's coming back. Even up here, we never change a polyatomic. We can't take the 3 or the 4 off. All we do is add a parentheses with a number, but we never, ever, 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 ever change a polyatomic ion. So what is this compound then? What is this compound? Let's see. Ca3P2. Well, Ca is calcium. I'll write down calcium. P is phosphorus. How do I make that IDE? That's phosphide. And why did I change that one to IDE? Because it's a monatomic anion. That means a single element that's negatively charged. That's what that means. All right. Let's do this one. Li2SO4, and then we'll do Li2. I said 4 but wrote 3. We'll do Li2SO4 here. So this is lithium sulfite and this is lithium sulfate. What if I write Li2S? Then that's lithium sulfide. And so we have to be careful. Those 3 letters at the end of each one of those sulf words all mean different things, and so we have to be very careful there. Okay, let's finish up. What if we have one of the special elements? You remember the special elements, like Fe can be +2 or +3. Lead can be +2 or +4. We listed them in class. So if you didn't get those in class, get those from somebody. These guys need to get Roman numerals in their names. Where do Roman numerals go? Did you say names? In their names. So, for example, what is if we're given this compound, FeO, what is that? Well, that's going to be iron something oxide. What is the something? You guys have to figure it out. Now, you already know by default it's either 2 or 3, so let's look over here. If oxygen is -2, iron has to be plus, why did I write a 3? It has to be +2 to cancel that out, so that's iron 2 oxide. Now, what if the formula were Fe2O3? Well, we still know that it's iron something oxide. Isn't that cool? But we need to designate which charge the iron's going to have. If oxygen has... this one's a little bit trickier. Some students like to do a method that I call crisscross backwards. I don't like crisscross backwards. It doesn't work in every situation, and I like to show you things that work in every situation. Oxygen is -2, so -2, -2, and -2 make -6. So this side has to be +6 to cancel. So what does each Fe have to be? +3. So we'll put a Roman numeral 3 in that one. One more, maybe 2 more examples. What about PbSO4 2? Now, for the people who like to crisscross backwards, they will get this one wrong. That's why I do not like for you to use that method. That's definitely lead, and SO4 is definitely sulfate. Now, if I'm drawing this out, I've got SO4, SO4. I've got 2 SO4s and 1 Pb. And SO4 has a -2 charge. I know that because I looked in my polyatomic chart. And -2 and -2 make -4 total. So what does this side have to be? +4. So that is lead 4 sulfate. Lead 4 sulfate. And one more example. 10 carbonate. So SN is 10 and CO3 is carbonate. A lot of students take this 3 and they just go, oh, I'll just crisscross that backwards. That's not correct. You can't do that because 3 is part of the polyatomic. How many carbonates are present? You shouldn't be saying to yourself, oh, there's only 1 carbonate present, so that's a -2. And so what does this 10 have to be to cancel that -2? If you said +2, you are correct. Correct. Now, remember, these are all ionic. These are all ionic compounds. What does that mean? They all begin with a metal or ammonium. That's very important. So in your big packet, you got to pay attention to which is which. Thank you for listening.